Hi everyone. In today's lesson, we're going to talk about how we can use logs to solve equations. Before we start this lesson, it's very important that you grab your calculator. So if you don't have it out with you, please pause the video until you have it. Okay, so before we can begin, I'd like to recall a few things. One first thing is that ln of e equals 1. Let's prove it. ln of e is the same thing as saying log base e. Right? ln is the same thing as saying log base e. So it's log base e of e equals 1. And we could do the loop-de-loop to prove this. So e to the first power, does that equal e? Absolutely. So this is going to come in handy a little bit later on. I just wanted to make sure that we remember that. Okay, the second thing I want to talk about is common bases. It's been a while since we've done it, but let's look at this example here. So we have 64 to the 2x plus 1 and 16 to the 3x plus 2. If I want to solve for the exponents, the values that are up here, we'd have to find a common base. Now with 64 and 16, you could use either 2 or you could use 4. I'm going to use 4. So what you would do is rewrite 64 as 4 to the third, and raise that to the 2x plus 1 power. You would take 16, raise it to the, or not raise it, sorry, rewrite 16 as 4 squared, and you'd be left raising it to the 3x plus 2 power. And then we would distribute the powers in, so we'd have 4 to the 6x plus 3 equals 4 to the 6x plus 4. We'd cross off the bases, and we would set the exponents equal to each other, and we would eventually do some solving, and we'd get an answer. That's all well and good, but what about solving an example like this? 64 to the 2x plus 1 equals 6. Can I rewrite 6 using 4 or 2 or even 8? Like 64 is either 4 to the third, 2 to the 6th, or 8 squared. Is there any way that I can write 6, this 6 over here, with one of these bases? No. So we have a problem. We cannot find a common base. So the question arises, how are we supposed to solve these things? And the question, or the answer to this question, is logs. Alright, so let's fill in the blanks down here. When you are trying to solve for an exponent in an equation and you can't find a common base, you must use logs to solve. So let's read it again. When you're trying to solve for an exponent, meaning the variable is in the exponent, in an equation, and you can't find a common base, you must use logs to solve. So here, in this example, we're trying to find the exponent. We're trying to find what x is, and x is located in the exponent. We couldn't find a common base, so we're going to have to use logs to solve it. So here are the steps on how to use logs to solve these equations. So let's look at an example and go through the steps. So the first one, it's obvious. There's no way I can find a common base. No way. There's no way I can write 5 with a base of 3 or 3 with a base of 5. So the first thing that you want to do is isolate the base with the variable and the exponent. Here's the base with the variable and the exponent. It's isolated on one side of the equal sign. Perfect. So now here's the trick. You know how you can multiply both sides of the equation by 2 or 4 or add or subtract and it's all the same? We can log both sides of an equation. So we're just going to basically say whatever I do to one side, I'm going to do to the other. So I'm literally going to add a log. So we're going to do log to the 3x equals log 5. Okay? Then we're going to have to use our log properties to take this power and drop it like it's hot. So x times log of 3 equals log of 5. Now to get x by itself, all you have to do is divide by log of 3. So x is equal to this. Please type this into your calculator. You don't have to use that change of base formula in the calculator. You could just hit the log that's next to the 7. So in the calculator, you have your screen that looks like this. You have a 7, and then right next to it, you have something that says log. Use this one. Use the log. Okay? So type in log of 5 divided by log of 3. Please use alpha y equals numerator over denominator. So put it in as a fraction. So hit alpha y equals numerator over denominator, type in log of 5, and divide it by log of 3. Alright, so we're going to round our answers all to the nearest tenth. So we should be getting 1.46 for ... So rounded to the nearest tenth is 1.5. That would be your answer. Okay, let's look at a second example. So 8 and 6, again, can't find a common base with that. So is the first step, is this exponent that's attached to this base isolated on one side of the equal sign? The answer is yes. So then we're going to log both sides. So let's write that down. We're going to log 8 to the x plus 3. We're going to log 6. Then we're going to use properties. Take the power, drop it like it's hot. So x plus 3, this whole thing, times log of 8 equals log of 6. Okay, now what we could do is we could divide this log of 8 and get this by itself. So let's divide log of 8, divide log of 8. So we get x plus 3 equals. Alright, pause the video, put in log of 6 divided by log of 8 in the calculator and hit resume when you're done. Okay, you should be getting 0.86165 ... Keep that number open in your calculator. And what we're going to do to get x by itself now is just subtract 3. So since that 0.86 is already in your calculator, just hit minus 3. And your final answer for x should be negative 2.138. Rounded to the nearest tenth, negative 2.1. Perfect. All right, let's go on to the next page and see what more examples we can do. Okay, example number 3 is a little bit different because the base is not isolated. So the base with the exponent needs to be isolated on one side of the equal sign. So the first thing you should do is you should add 3 on both sides. So now we have 6 to the 2x equals 103. So now we are in good shape. We have our base that's attached to our exponent on one side of the equal sign. We could drop it like it's hot and log both sides. So 2x log 6 equals log 103. I kind of combined two steps here. If you feel comfortable doing that, you can. Otherwise, you can include this first step here, which would be log of 6 to the 2x equals log of 103. I just knew that I had to drop the power and log, so I figure I can do it in one step. Okay, now what I can do is divide by 2 and log of 6. So the log of 6 will cancel, the 2 will cancel. So I have 2 log 6 on the bottom. As long as you're using alpha y equals, you won't get this question wrong. So use alpha y equals, numerator over denominator, put in log 103 divided by 2 log of 6. And your answer should be 1.293. Rounded to the nearest tenth is 1.3. Okay, let's try example number 4. So we have 5e to the 2x. I need to isolate this e to the 2x. So the first thing we should do is divide both sides by 5. So we have e to the 2x equals 10. Now we can continue on what we've always done. We can log both sides and drop it like it's hot. So we'll drop it and log it at the same time. So 2x log of e equals log of 10. We could divide both sides by the 2 and log of e. These will all cancel. 2 log of e. So now as long as you use, when you put this into the calculator, as long as you use alpha y equals, you should get the right answer. So pause the video until you can do that. Okay, you should be getting x equals 1.15, 12 dot 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 dot. So rounded to the nearest tenth, you should get 1.2. Okay, there is another way to do types of problems that have e's in them. So let's do number 5 in a different way. And number 5, the way that I'm doing number 5 is the way that I would prefer you to do everything that you see when you see an ln. So first let's divide by the 150. So in the calculator, type in 340 divided by 150, and you should be getting some weird decimal. So hit math, enter, enter, and get a reduced fraction. So you should get 34 over 15, and we have e to the 0.05x. Now, it's better to use, when I see an e, it's better to use ln. So let's write down better to use ln when you have e. Okay, the ln button is located right next to the 4 on your calculator. Okay, so what do I mean by it's better to use ln? So we have the same problem here that we had up here. We would drop the power and log both sides. So here we're going to do the same thing. We're going to drop the power, so 0.05x, but now we're going to ln both sides. Okay? And we're going to let the calculator do all this work for us. Now this, ln of e, what makes this a little bit easier is that you have ln of e, and we know that that equals 1 from the front page of this worksheet. So we've got 0.05x times 1. So that's 0.05x equals ln of 34 over 15. Divide both sides by 0.05. So take a minute, put this into the calculator, just the way you see it, and hit resume once you've done so. Okay, your answer should be -30.3 when you round it. So that is your final answer. Okay, I think that's enough for today. If you feel like you want to try examples 6, 7, and 8, by all means try them. You don't have to try them. I'll post the answers right after I'm done speaking, and you can check them. Okay, have a nice day. Okay, here's your answer for number 6. Okay, and here are your answers for 7 and 8. If you have any questions, ask us in class tomorrow.